In this video, we're going to look at the horizontal line test. The horizontal line test is used much like the vertical line test. So let's look back at the vertical line test. The vertical line test was a test that we used to find repeated x values. We have a graph, and we want to know, does that graph represent a function? The vertical line test says that if any vertical line that you draw only crosses the graph in one point, then it is a function. If you can draw a vertical line that touches the graph in more than one point, then it is not a function, and we say it would fail the vertical line test. So the vertical line test tells us if the graph we see is a function by looking for repeated x values. The horizontal line test tells us if the function we see is one-to-one. So the horizontal line test is testing for one-to-oneness. In other words, the horizontal line test will tell us, do we have any repeated y values? So we're going to call this a repeated y value detector. For a function to be what we call one-to-one, there's two requirements. For a function to be one-to-one, you can have no repeated x's and also no repeated y's. So the graph is not allowed to have any repeated x's or any repeated y's in order for the graph to be one-to-one. We use the horizontal line test to look for repeated y's. So the first picture that we see here, we see that we have a vertical line that crosses, the horizontal line that crosses that graph more than once. This fails the horizontal line test. So we notice that what it has found is repeated y's. So we have a horizontal line that intersects the graph at more than one point. If a horizontal line intersects the graph at more than one point, then we have found repeated y values. If we have repeated y values, then we say that the graph fails the horizontal line test. What does it mean for a graph to fail the horizontal line test? If a graph fails the horizontal line test, then that means that we have repeated y values. If we have repeated y values, that means that the function that we see is not one-to-one. If the function we see is not one-to-one, then it has no inverse function. So essentially all four of these pieces of information means the same thing. If you have a function that fails the horizontal line test, that means the function you see is not one-to-one. It means the function you see has repeated y values. It means the function you see has no inverse function. Why does the function we see have no inverse function? Well, if you were to take those ordered pairs for function f, so let's say we had function f, we see two ordered pairs, we see -2, 4, and we saw 2, 4. If you were to reverse those ordered pairs to create the f inverse list, it would be 4, -2 and 4, +2. So repeated y's for the function list, for the list of f, become repeated x's for the inverse function. So what you notice is over here, well, that would be 4, you would end up with an x value of 4 and a y value of 2. it would end up down here with an x value of 4 and a y value of -2. So when you look at the original function list of ordered pairs, it has repeated y values. When we reverse those ordered pairs, we create the list of f inverse. But now when we look at the list of f inverse, we see that we have repeated x's. Now what that means is that the inverse function would end up failing the vertical line test. So if you were to graph the inverse and look at all those ordered pairs, the graph of f inverse would fail the vertical line test. So if you were to reverse all of the ordered pairs for the original function f to create f inverse, you would have repeated x's for f inverse. F inverse would fail now the horizontal line test, and then it would not be a function. So the horizontal line test answers the question of one-to-oneness. But once it answers the question of one-to-oneness, then it also answers the question of, does that function have an inverse function? So the horizontal line test. The horizontal line test tests a function for one-to-oneness. If a function is one-to-one and passes the horizontal line test, then it does have an inverse function. If the horizontal line test fails, then the function we see is not one-to-one and does not have an inverse function. So let's look at some more examples. Does graph A have an inverse function? Okay, to answer that question, what we want to know is, does it pass the horizontal line test? Every vertical line that I could possibly imagine drawing for this graph A only crosses through the graph once. So we would say that it passes the horizontal line test. And I'm going to abbreviate that as HLT, but it passes the horizontal line test. If it passes the horizontal line test, that means that the function we see, so the function we see is f. F is a 1-to-1 function. What also does that imply? If f passes the horizontal line test, and if f is a one-to-one function, then f has an inverse function. And that was our question. Does f have an inverse function? And the answer to this question over here is yes. Okay, but let's look at graph B. When we look at graph B, the first horizontal line that I could possibly imagine drawing intersects the graph at more than one point. It intersects the graph at 2 places. So in this case, I would say that this graph fails, the horizontal line test. I'm going to abbreviate horizontal line test as HLT. So we draw a horizontal line, touches the graph at more than one point, so it fails the horizontal line test. So if our graph that we see fails the horizontal line test, that means that f is not a one-to-one function. And if f is not a one-to-one function and fails the horizontal line test, then f has no inverse function. And that was our question. Does f have an inverse function? And so now we have an answer for that. Our answer then would be no. Okay, I'm going to leave the other 2 examples to you. I will complete them, and I will put them in the completed notes. But I want you to try those 2 and then see how you do.